Okay, it says we're live. And for those watching on YouTube, hang out for a minute. We're going to do a little housekeeping, post link somewhere, and then we'll get this meeting going. Okay. Yeah, it looks like we're live. Got the link. That there. I'm going to update the agenda with the link. And I'm going to update the agenda with a link to your bcp-js. Okay, the agenda's been updated. Okay, well, thanks for attending the technical steering committee, guys. Looks like it's just the three of us. Let's just quickly go around and introduce ourselves before we get started. I'm Chris Troutner. I founded the Permissionless Software Foundation and FullStack.Cash, which is a blockchain as a service for both the Bitcoin Cash and eCash blockchains. And yeah, we're going to talk about some of the software updates today that has been going on around FullStack.Cash. Stoyan, why don't you introduce yourself?
My name is Stoyan and I'm helping with some of the JavaScript libraries like bcp-js for the PCF. Yes.
Hey, I'm Joey King. I'm a JavaScript developer currently working for Bitcoin ABC. I'm working on the Cash Tab family of web apps.
Nice. And I encourage everybody to check out Cash Tab as it's a pretty cool app and browser extension. Okay, so let's go to the agenda. Pretty short one today. The main thing I wanted to cover was some major refactors that landed on bch-api with regard to the rate limiting. And this is going to affect users of FullStack.Cash, and it added some features that users requested for bch-api. I'm going to also introduce some changes that have not been made yet, but will be made soon and could potentially be disruptive to Minimal SLP Wallet, which is the wallet engine behind wallet.fullstack.cash and some of the other wallet apps under the FullStack.cash umbrella. And then, I named this incorrectly, Stoyan, but Stoyan's going to introduce us to bcp-js after that. So let me just dive in here. This is the repository for bch-api, and this is a fundamental part of what we've been calling the cache stack. So it's the REST API component that talks to all the lower level infrastructure like the full node, the SLP DB indexer, and the Fulcrum indexer. So this is sort of a rough diagram here. And the way FullStack.Cash works is there's these rate limits, and there's actually in talking with users and looking at the business of FullStack.Cash and talking to some of the companies that also use the FullStack.Cash infrastructure that run their own isolated infrastructure separate from the tiered services. There's really four use cases that we needed to target. The first is users who this is actually a corner case. One I'm building up to is users who want to buy a JOT token for access for a short period of time, like 24 hours. This is not a use case that's really being used right now, but it's something that I want to target going forward. Also, I've gotten requests from users. Previously, I only had the 100 rate per minute or request per minute tier, and they requested higher RPM tiers. So now we have a 100, a 250, and a 600 RPM tier for people who need higher rate limits. And the main reason well, I'll go into the reason why we need more. The third major use case we're targeting is basic authentication, which should not have any rate limits applied. This is actually probably the major use case for clients of fullstack.cash who want to run isolated infrastructure for their company. They want the system to run as fast as possible. They don't want to be exposed to rate limits, but they still need some sort of authentication so that their servers are not publicly available, so that they're the only ones using their servers. So that's basic authentication. The fourth use case is local installations that do not use either any sort of basic authentication or any sort of rate limits. So for that use case, for like the hobbyists and developers working locally, bch-api now has this do not use rate limit flag. It's an environment variable. So if you set that to anything other, like to anything, really, if it just exists, then it will skip this block and it will not implement either rate limits or basic authentication. And then for the basic auth, that hasn't really changed for those. We did more thorough testing so that the rate limits are truly not being applied. And we added unit tests to make sure that the system's actually working the way we expect it to. Let me talk for a minute about these higher rate limits. So one of the trade-offs I've been bumping up against, and Joey, you and I talked about this a while ago, is this sort of this concept of heavy API calls. There's very simple API calls like get transaction information, which is just one call to a full node. And then there's these heavy calls like hydrate UTXOs or get public key or UTXO.get. These are some of these newer higher level abstraction calls that actually set off, they're one API call, but they set off a chain reaction of APIs. And so they're heavy in that they are much more CPU intensive to the server. And so the trade-off I've been wrestling with is, how do we make it fair? How do we make the people who are using the heavy APIs, how do we charge them fairly for the people who are using the lower level APIs? And so this is the big change that happened with this rate limit refactor, is that heavy, like if you call hydrate UTXOs, which is just one API call, it's going to, all the other API calls that that sets off that chain reaction, that's going to count against the user's rate limits. And so it makes the heavy API calls, it's fair, like, and it lets us lets fullstack.cash add more and more higher level abstraction calls. We've got like one call we want to add is a transaction call where you get the addresses of both the inputs and the outputs, as well as any SLP token amounts for inputs and outputs. That it requires quite a bit of computation to get all that information together. And so that's gonna be another high or heavy API type call we want to add. Another one is the balance of an address over time. So that basically it's a transaction history, but every entry in that transaction history like has an accumulated balance, so you can see the balance of an address over time. So these are like feature requests that people have been submitting, and we want to provide them, but they're very heavy API heavy calls. And so this refactor is going to let us push forward by adding these new desired features, but keep everything fair. But that's also why we needed higher RPM tiers, because the 100 RPM tier is not going to go as far as it did in the past. And as a result, we lowered the price. So at fullstack.cash, the 100 RPM tier is $10 a month. The 250 RPM tier is $20 a month, and the 600 RPM tier is $30 a month. And then from there, you can start to jump into isolated infrastructure. So just trying to offer more options to our users was the main motivation. So that's the main change that's happened to bch-api. And now that that's been done, there's this UTXOs get API call, which is a very handy API call. And you give it an address and it retrieves all the UTXOs. And then this new little bit that I've never seen anybody do, as far as I'm aware, we're the only ones who do this. It does this very nice sorting of the UTXOs so that so you get this nice BCH UTXOs array, and those are verified that you can spend them and they are not tokens and you can safely spend them. There's if it's an SLP UTXO, it'll get categorized, whether it's token type 1 or an NFT, a minting baton, or other things like that. Each UTXO will get categorized and dropped into an array for its category. And then anything, because we live in a messy world and things get messy and we hit rate limits, anything that can't be verified in that one call will get thrown into this null UTXO sort of bucket array. And that way a wallet app can safely just ignore those UTXOs or try to hydrate them on a second call. But basically it's exception handling. And so this function's been around for a little bit, but it's very different from the way that minimal SLP wallet works now, which again is the sort of core wallet engine that the web wallet uses. And so we're gonna, over the next week or two, the focus is going to be on doing a heavy refactor of minimal SLP wallet to make use of this call. Yeah, so that's basically what's coming down the pike. Do you guys have any questions about that?
No, we was talking about this from several weeks, so yeah, it's not a big news. Just
yeah,
we are happy with the progress made.
Yeah. No surprises for those who've been paying attention. Well, that's all that was on the agenda. And Stoyan, I'm really keen to hear about this bcp-js. Why don't you tell us about it?
Can I share my screen?
Yeah,
try,
let me
maybe.
turn that on. Okay, you should be able to share now.
Okay, so I need to desktop. To which one? This one? Let's try this one. Share.
Yeah, there we go.
Can you see this?
Looking good.
Okay, so I have a little proposal for the protocol named blockchain payloads or blockchain pointers, whatever will be. So like BCP. And what is all this about? In the moment, there's already a lot of different type of NFT tokens. With type, I mean the way they connect the information on the blockchain, the NFT record itself, and the media which is connected to this NFT, like images, audios. All of them are doing this differently. So for the wallet developers and for exchange developers, it's pretty difficult. They need to implement all of these tokens differently to show, for example, the images. So this proposal is mostly for the way how to describe, how to create a little pointer to different resources, like for example, IPFS hashes or usually other transactions on the blockchain. So I used for a model, like we was talking about this media sharing protocol by you, Chris, and also, but it's based on memo.cache. So I wanted to go even lower. So I also read this swap protocol by Winner Money. So physically, this protocol is in fact just a simple op return transaction. Yes, op return transaction. It have its own lockat and only 3 parts, which the first one is the message type of this data. It's very convenient because you can from here get only audio files, for example. If you want to do only audio like stuff or only video files, or in the moment this waifu type, you can just get this one.
Cool.
And yeah, the second part is where is this data like located? And it can be inside the transaction itself. Like it can be simple text encoded in this op return. So it will become like same like memo cache maybe. Or it can be another transaction which will be represented like transaction ID. Or it can be URL, which is possible, not very good, but yeah, it can point to some URL resource. And the best one is like it can be some IPFS hash.
That's great. It's great to have those options.
Yeah, it can be. I also added here like Bitcoin file protocol, but it's not implemented still. But it's possible option.
Right.
And the last part is the final like the real data need to point to this resource. It will be different for every source. For IPFS, it will be the hash. For URL, it will be the URL itself. For the transaction type, it will be transaction ID. And here is some example transaction, like op return, this one.
Okay. I'm curious what was your thinking there with using locat IDs versus like the memo.cache IDs?
I wanted to be a separate protocol because this one can be used by itself, not connected to NFT even at all. It's pointers to data. You can just save on the blockchain pointers to what you want. We was talking about the pointers to SIP, this SIP call. So when you can get this and make a phone call to somebody, something like this one. So yeah. I don't think it's text in all cases. It can be memo cache, but I want it to be even lower. So yes, I implemented. So this is the proposal. It's pretty simple. And I also implemented the JavaScript library for this one. It's ready. It can be used even now.
Nice. So
it depends only from big number, no other dependencies. I used this SOP media maker, very low level one for a model, and SOP parser. But this one depends only from bit number. And it's very easy to use it. You can include it in your browser, or you can just install it. It have some convenient method, like you can create these op returns with any type you like and any source, or you can use some wrappers around this one to be even more easier. Like if you want to create a pointer to audio file, you just create audio. You put here, where is this? IPFS, for example, and here the hash.
Nice. So this library is just for generating the op return.
It's only for op returns.
Yeah.
So the next step, and when you generate this kind of op returns inside the NFTs, you just put the transaction ID of this guy on the BSP. So NFT connects to BCP, and BCP connects to the real data.
Very cool.
And yeah, and here is how the magic working, the real working example. Like, for example, you can search for audio files. So I created several NFTs already pointing to this kind of stuff. So inside the ticker, you put some special like BCP audio, and you can see I have 2 BCP audio NFTs. And
so,
if you go,
so the pointer is going in the op return, but that's also used by the SLP data.
It's optional, but if you have this inside the NFT ticker, you don't need to go to get the BCP and then see the type. You can see it immediately here in the ticker.
Okay. So the op return data that your BCP library is generating, does that go into a separate transaction, and then you put the transaction hash in the document hash of the token? Is that how this works?
I will show you now.
Okay.
So there is the two tokens in the moment, the real one existing already on the blockchain. One is
Cool.
pointing to the audio with the rain drops. Another one is SOS Morse signal. So yeah, let's see this one. If you go there, you can see it's a usual NFT child, which is originating from some group. And yeah, this one is the ticker. So from here, I figure that it's an audio. It's optional step, but it's very convenient.
Mm-hmm.
And the magic is here. The document URL now is pointing to something, which is a transaction on the blockchain with this BCP. So if you go there and see this transaction,
this is really interesting. This I hadn't thought about putting a transaction hash into the URL.
So if you see this transaction, it's just one op return. And if you see this op return, you can see it's this low cut, and it's like audio type, and it's IPFS type. Mm-hmm. And because of this, you can get the IPFS hash. So with this guy, you're just going to IPFS. And yeah, it's slow, but it will eventually return the real one.
Yeah, well, while we wait for that to come up, so I like that you used Locat ID. I haven't played around. I think the main advantage to doing that is that BitDB can index Locat IDs. It's already built for that. So if you want to build an indexer to track these types of transactions on the blockchain, that would probably be the lowest hanging fruit.
Yeah, but I don't think it's how to see. I was thinking also, but you don't need to implement indexers especially for these guys, because they will be NFTs payloads. So all of the stuff will be done on the NFT level. Eventually, somebody can be interested to only index these guys, but yeah, maybe in the future.
Well, that's a really good point, Stoyan. Yeah, because when you're talking about, so this is very similar to, there it is. There's the media. Raindrops. This is interesting because where you really need the indexing is a marketplace, like an order book. But that's not this. This is just a payload for an NFT. So that's an interesting thought. And then there's something else I thought was really interesting that you said, but it's escaping me at the moment.
Because I can have with this thing, I can have now several NFTs pointing to the same context. Like in case of the like this game stuff, you can have 5, for example, tokens pointing to the same context. You just have the same URLs inside. So
interesting.
It's pretty, it's like adding this middle level of BCPs will increase a lot of NFT usage, I think.
Yeah, and also like you could extend this protocol to point to mutable data. I've got another spec that's similar to this in the PSF specifications repo. So if that transaction ID, if instead pointing to a transaction with an op return, if instead that op return pointed back to an address, then a wall, and this is essentially what that mutable data pointer spec is all about, is then a wallet can look at the transaction history of that address, and that can change over time. That's mutable. Get the latest pointer, which is the latest transaction at that address. So that's how in this spec you can take an immutable token and point it to mutable data. So like a video game character whose stats change over time, you could represent that character as an NFT, but the state of that character can change over time.
It can be maybe, it can point to another stuff, or maybe what I can add the address type, pointing to address directly.
Mm-hmm.
So for example, if you see AD error, it will be the Bitcoin address or SOP address.
Yeah, that would be a great, addition. Because that would open the door to this whole mutable data thing.
Yeah. So yeah, it's very easy. It's just the parser is like pretty easy to be extended.
I love that approach that you took. Like, this library is just for generating op return. That's the only thing we're going to worry about. That way you don't have to have any
for
dependencies.
generating and for parsing. You can parse this already. Op returns data, you can parse them. It will return you a JavaScript object with the type, the source, and the data, everything. It's doing both way, like from JavaScript object to op return data, and from op return data back to the stuff. So you can get from the blockchain this op return, parse it, it will give you the object. So you can get everything from there.
Very cool, man. Wow, very cool. This is great. Like, you just blew my mind. I'm like trying to think of like all the different ways we could use this library. There's a lot of them. Wow, cool. I can't wait to play with this library. This is really interesting. And like the whole like idea that like you don't need an indexer, that's kind of blowing my mind.
Yeah, NFTs will be indexed because they already have everything implemented. No need to do this again.
Yeah. Wow. Very cool. Great work, Stoyan. Wow.
I hope somebody, how to say, of the wallet developers and the exchange developers also agree, so people will start using this one.
Yeah, well, I mean, you're on the forefront, and everybody's kind of figuring it out right now. So that's, hopefully our work can converge here soon. Once we get the UTXO get call implemented into minimal SOP wallet, that'll let wallet.fullstack.cache, that'll let us start building a plugin for NFTs and for different types of use cases around NFTs, because they'll be able to just tap right into those categorized UTXOs. And then this is really interesting. Like that mutable pointing to mutable data spec. A lot of businesses have been interested in that, but not so much that they've wanted to fund, development of it. And so if we build some NFT plugins that make use of this BCP library, I mean, then that opens several doors. Like, it opens like, a generic NFT use case, but then this whole mutable data thing, and then the fact that you support different media types and different file formats makes it really flexible.
About this new, how to see, address source, you can have it even tomorrow. It's very simple change, so you can start playing with it.
Cool. Yeah. This is beautiful. I love how all these different things are coming together.
Okay.
Right on. Okay, well, I think we can probably wrap it up with that. Joey, you got anything? No? Okay. Cool. All right. Well, I'll see you guys in the Permissionless Software Foundation Telegram chat room. Stoyan, I can't wait to play with your software. And we'll have a ComCom meeting at this time next week. And then I'm probably going to postpone the technical steering committee meeting in 2 weeks from now. I'll have a medical appointment I need to attend, so I won't be able to host that. But I guess I will see you guys online.
Yes.
Sounds good. Thanks for